So there are three measures of productivity: total product, average product, marginal product. We just looked at total product, so we looked at the total quantity that's produced as we change the number of workers. And so we found that as we hire more people, the output, the total product increases until at some point you have your maximum produced and then it starts to decline. We want to look at the next measure of productivity, which is average product. And we're going to look at particularly the average product of labor. So we're going to take total product, the amount produced, and divide it by some input. If we're using the average product of labor, that input is the number of workers. So we're looking at how much the typical worker can make. Total product divided by labor. So let's do those calculations, and we are going to take total product divided by labor. So here, when we do average product, when we have zero labor, 0 divided by 0, anytime you put 0 in the bottom of your calculation, it's undefined, so we just skip that one. Okay, now we want to take total product divided by labor. So if we have one worker producing 6 units, then the average worker makes 6 units. When we made 7 units, we had 2 workers. So 7 divided by 2, okay, 7 divided by 2, right, we get 3.5. So the average worker in that case is making 3.5 units. Well, what about when we produced 11 units and we had 3 workers? So 11 divided by 3. We get 3.67. All right, so take a moment and do the other calculations as well. So what happens to the amount produced per worker as we add additional workers? So we'll take our 13 divided by 4. We get 3.25. And our 15 divided by 5, now 15 divided by 5 is 3. And 15 divided by 6, 2.5. Okay. And 13 divided by 7 is 1.85. All right, so what do we notice about our average product here? So how much are we getting from the typical worker? And so what we would do is we would take this information and we can plot it on a graph. And so here we have our number of widgets on the vertical. We have our number of units of labor on the horizontal. And let's just let's make this on a 10-point scale here. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and so we found when there was 1 worker, we were at 6. And we found that at 2 workers, it's 3.5. And then we see that, wrong one. And then we see we go up to 3.67. So we'll show that little bump there. And then we go to 3.25. And then we go to 3. And 2.5. And 1.85. Okay. So here we have our average product of labor. In the production that this group of students did, what happens is you hire that first worker. They were producing a lot of units per worker because there was just one of them making 6. And then as we added the additional workers, then the amount made per worker, because they weren't increasing their output substantially, as we take the total product, the amount produced, and we spread it across more workers, we're seeing this average product of labor. It went up a little bit here and then continued to decline. We're going to look at why the average product of labor might have this shape or a different shape in just a moment. But in order to have that discussion, we need to first talk about another measure of productivity. And this is the marginal product. So marginal product is the extra produced when we add more unit of input. And in this case, we are adding labor. So we're going to look at the marginal product of labor. Now, when you look at this formula, you see this triangle here. This is a mathematical symbol called delta, and delta means change. So we're looking at the change in total product when you change the amount of labor. So in this case, we're adding workers at a rate of 1 at a time. So we're going to be changing labor. Our change in labor is going to be equal to 1. But it's also possible you could hire people, let's say 5 at a time, in which case your change in labor wouldn't be 1, but we'd be looking at it, that denominator, as 5. So we want to look at how much does output change as we add an additional unit of input. So let's go back to our example here. And so when we find marginal product, it's the change in total product divided by the change in labor. So what happens here is we skip the first one. Now notice when we go from 0 to 1 worker, the change in labor is 1. And the change in output goes from 0 to 6. So 6 minus 0 is 6. 6 divided by 1 is 6. Now when we go and hire the second person, the change in labor, we go from 1 to 2. So the change in labor is 1. And the total product goes from 6 to 7. So here, the marginal product, the extra produced when we add 1 more worker, is 1. When we go from having 2 workers to 3 workers, we change the labor by 1. And we change the total product, 11 minus 7, changes by 4. Okay. Then when we go to hire the 4th worker, we're going from 3 to 4 in our labor, so the change in labor is 1. And the total product goes from 11 to 13, which is a change of 2. Then when we go from 4 workers to 5 workers, we're changing labor by 1. The total product is changing from 13 to 15, which is a change of 2. And then when we go and hire the 6th worker, we are hiring 1 more labor. 6 minus 5 is 1. And total product goes from 15 to 15, which is a change of 0. Then when we hire the 7th worker, we are getting 1 more unit of labor, and our output goes from 15 to 13, which is a decrease of 2. So our marginal product, we have 614,220, negative 2. We want to plot that information on the same graph as our average product, because we said that when we look at the shape of average product, in order to really understand it, we also need to understand what's happening with marginal product. So let's graph that information for marginal product. So we look at 614, so 6, 1, and then above that one at 4. And then we have 2, 2. And then we have 0 and negative 2. 0 and negative 2. Okay, so let's draw that marginal product. It goes down, and then we go up, and then we go down. Oops. Trying to freehand this here. There we go. Marginal product of labor. All right, let's talk about what these graphs are telling us. So what happened is when we hired the second worker, they added 1 unit to production. So that extra worker, that second worker, didn't add very much. And so what happens is when marginal product is less than the average product, what happens to the average? Well, we can see the average product goes down. We hire someone who doesn't add as much as the person before, which will pull the average down. You can think about it this way. Let's suppose in our class we were looking at the average weight of the class. Okay, so what's the average weight in our class? Let's say it's 140. Okay, so if the average weight in our class is 140 and in comes Skinny Minnie, who weighs 70 pounds, way less than everyone else, then the extra weight we're adding to the class by having Skinny Minnie come in is only that 70 pounds. So if we were then to recalculate the average for the class, if the average weight was 140, bringing in Skinny Minnie, what pulls the average down? So if the extra person is adding less than the group, then it's going to pull the group average down. Now, if the marginal product is more than the average product, so here we see when we go to add the third person added more, okay, than the average, than the rest of the group, than the typical for the group. So this would be like our class weight being 140, and Sumo Sam comes in the room weighing 400 pounds. Okay, what does that 400 extra pounds do to the class average? Well, it makes the average weight go up. So when the marginal is above the average, it makes the average go up. So there's a tie between the average product of labor and the marginal product of labor. The average product of labor is the typical worker, how much can they produce, but it's going to be highly dependent on the marginal product, the extra that's produced when we add the next worker. And so if we add a worker who contributes less, it pulls the average down. And if we add a worker who adds more than the average, then it's going to pull the average up. So our two graphs here are tied together in terms of their shape. Now, why does our graph look like this from this class example? Well, it really depends on how the group rearranges the workload. So we said before, you're folding a paper twice and stapling. When we look at the extra that is added by the next worker, what happens depends on what kind of job we give the next worker. So we want to dig into this shape in a little bit more detail by understanding what could cause the marginal product of labor to go up and what could cause the marginal product of labor to go down. So when we look at the theoretical graphs for average product and marginal product, average product tends to have this shape here. And marginal product will have this shape. Okay, so we need to figure out what causes our marginal product to go up, because we know that when the marginal is above the average, it pulls the average up. And we need to figure out what makes the marginal go down, because when the marginal is below the average, like here, it's going to make that average start to decrease. And we need to recognize why the marginal product becomes negative. Well, if we go back to our example here, notice that the marginal product of labor became negative at 7 workers. So here, when we add the 7th worker, they are reducing the amount. They're not adding to the production, they're reducing. And here, at the 6th worker, when we add that 6th worker, they were adding nothing to production. Well, we've actually seen those 2 points already, because the 6th worker, remember, didn't add anything to production, so total product was the same at both 5 and 6 workers. And when we hired the 7th worker, remember, total product went down. So the fact that this total product decreased with the 7th worker is why this marginal product is negative. And the fact the total product didn't change when we hired the 6th worker is why this marginal product is here at 0. Okay, so we know why we might get 0 or negative marginal products. The question is why does the marginal product go up or down? Well, let's start about why the marginal product would go up. So our marginal product goes up when we take advantage of divisions of labor. So divisions of labor is where we can take our tasks and we can divide them up into different specialized tasks. So when it comes to making our widgets, what are the different tasks we can do? Well, one task is to fold the first time. One task is to fold the second time. One task is to staple. So we can divide this job up into different specialized tasks. If we assign each of those tasks to a different person, then what we find is that more people, so if we have 2 people, for example, let's say one is doing the folding, one is doing the stapling, then 2 people can work more than twice as fast. So if we have one person fold, another person staple, we get more than if we have one person folding and stapling, one person folding and stapling. Now remember, in our demo, we have one stapler. So the reason that we're not getting 2 people working twice as fast, if they were separated, they would have to share the stapler, okay? So if they're sharing the stapler, then we can't get 2 people working twice as fast both separately because they'd have to keep passing the stapler back and forth. So if we have one person fold and one person constantly stapling, we should get more than twice as much than if they were to work independently and have to pass the stapler back and forth. So when we look at our demo, when we hire people and we give them a unique task, then what happens is our marginal product goes up. So we can see here in our demo that the marginal product went up when they hired the 3rd worker. And that's because in the class that did this activity, when they divvied up the work so that they had one person folding the first time, one person folding the second time, one person stapling, we're dividing up into unique jobs. And so the 3 people were able to produce more than they would separately. But when we hire workers and we just give them a repeat task, okay? So if we hire a worker and all we do is have them fold and we already have someone folding, then what happens is that we're not taking advantage of that divisions of labor. So it's the divisions of labor, that specialization, that allows us to get extra from each additional worker. The marginal product goes up. And a good example of this is a clip from Big Bang Theory. So in our course, there's a link to a video from Big Bang Theory, and you can see where they're making penny blossoms. Notice that when the 2 of them make penny blossoms, that they're able to make more together than if they were both making penny blossoms separately. So we're taking advantage of divisions of labor by each doing a specialized task. Now, how come the marginal product of labor doesn't keep going up indefinitely? Well, when we made widgets, we could really only divide this work into kind of 3 different tasks, maybe 4. Because you could fold, one person could fold, another person could do the second fold, one person could feed, another person could staple. So you could probably get 4 specialized tasks out of these widgets. So that means as you start to hire more and more workers, right, as we hire the 5th worker, the 6th worker, the 7th worker, there's not a new unique job for them to do. So what happens is we get the law of diminishing returns. We get a decreasing marginal product. Okay, and that's because as we keep adding more and more workers, but we still have to share the one stapler. There's not unique work for those extra workers to do. And this fixed factor, right, is going to be the bottleneck in our production. It limits the amount we can produce. And so what then happens is that we add these workers, but they're not able to add as much to production. So marginal product goes down, we get diminishing returns. We add more workers, but we get less from each additional one. And it has to do with that fixed factor. If we could add more capital, then we could divvy up more of the jobs, right? We could have multiple people stapling. We could then have one group fold for one stapler, another group fold for another stapler. We could divvy up more of the work and continue to take advantage of those specialized tasks. But when we keep adding more and more worker and there's a fixed factor, those additional people are not adding as much to our output, so they're diminishing our returns. Now, notice when marginal product is going down, so marginal product is decreasing from 1 to 2. Our marginal product here is decreasing from 3, 4, 5, 6, 7. Notice, though, that when marginal product is decreasing, the total product here is still increasing. The difference is how quickly it's increasing. So when you have diminishing returns, when that marginal product is falling, not when it's negative, but when it's falling, what happens is it impacts the slope of that total product. So notice how it's steep and then it got flatter. That's that decreasing marginal product. Then it's steep, then it starts to get flatter. So when you have that decreasing marginal product, that diminishing returns caused by our fixed factor, we are adding less to our output, but we're still adding. Okay? It's only when you get negative marginal product that your total product starts to go down. But if the marginal product is increasing, then we're going to get a steep increase in our output. If marginal product is decreasing, then we're getting less additional output, but we're still getting more output. So we have this problem of diminishing marginal product. That is, we hire more workers, but they're not adding more than the person before. They're still adding, output is still increasing, but they're not adding as much as before. And so this is going to impact the amount of people we're willing to hire, because we need to look at how much extra they're adding, so the marginal product, and we also have to consider their extra cost. So we can't make decisions just based on productivity. We have to consider cost as well. Now, we said that the theoretical graphs for marginal product and average product is that you first get increasing marginal product, because that divisions of labor break into specialized tasks. Everyone does something different. Then we get more from each additional worker. We're adding to output at an increasing rate. Then at some point, you're going to start experiencing those diminishing returns. So we're adding additional workers, but because of that fixed factor, in this case our stapler, because we don't have another stapler, they're very expensive, then each additional worker adds less. Notice that even though we're adding less from each worker, as long as the marginal product is higher than the average keeps going up. It's only when the marginal product is below the average that it pulls the average down. And so once the marginal is below the average, we start to see the average decrease. So we can see here at this point, this is when our workers are the most productive. We've added each additional worker. They're adding more than the person before. We start to get the diminishing returns here. But our average keeps going up because each additional worker is adding more than the group. Here's where our workers are the most productive. Here's where we don't hire. Okay. We're going to look at a graph in a moment to interpret information about the business, but before we leave this relationship between average product and marginal product, I just want to illustrate once more this relationship between marginal product and average product. And here let's do it with some calculations. So let's suppose with one worker, they can make 4 widgets. Total product is 4 widgets. With 2 workers, total product is 6 widgets. So at the 2 workers, the average product, so 6 divided by 2, is 3. Okay. Now, before the average product, 4 widgets divided by 1 worker is 4. When we go from 1 worker to 2 workers, we're adding a worker. So remember, marginal product is the change in total product over the change in labor. The change in labor here is 1. Total product changes by 2. So notice that when we go from 1 worker to 2 worker, the extra made by that worker is 2 widgets. That 2 widgets is less than the current average. So if the extra if marginal product is less than the average product, it's going to make the average go down. And you can see the average when we have 2 workers is 3 widgets, which is less than the 4 that it was. So if the marginal is below the average, it pulls the average down. Well, what happens if when we go to add a worker, so let's say we go from 2 workers to 3 workers. And when we go from 2 workers to 3 workers, so we had an average product of labor we had of 3. And when we go from 2 workers to 3 workers, now with our 3 workers, our average product of labor, 3 workers, 12 widgets. So on average, they can make 4. Okay. When we go from 2 workers to 3 workers, the marginal product of labor, we are changing from 2 workers to 3 workers. So that's a change of 1 worker. And we are going from making 6 widgets to 12 widgets. So the change in total product is 6. So notice when we go from having 2 workers making 6 widgets to 3 workers making 12 widgets, the average went from 3 to 4. Now the average product went up because the marginal, the extra, we hired that 3rd worker, they added 6 widgets, is more than the average, which makes the average go up. So we can see it in the calculations here. You can see it in the graph. So if you can figure out what's happening on the margins, you know what will happen to the typical worker. All right, so why do we care about any of this? Well, let's suppose that this is the productivity graphs for your company. Okay, so here's your number of workers. Let's look at what we can tell about production. So what we know in terms of our maximum total product, we are producing the maximum amount when we have 8 units of labor. After 8 units of labor, notice that the marginal product will become negative. So each additional worker you add after worker 8, you're basically paying them to destroy stuff. The total product would go down. So you would not hire more than 8 people. You're just paying them to destroy things. Now, when you hire your first couple workers, we can see that they are adding additional units with each additional worker. Marginal product is going up, okay? And you can see that total product is steeper. As we add more workers, we're getting more and more output. Then we hit a point of diminishing returns where there's no longer ability to specialize in additional tasks. And it's really because we have some kind of fixed factor, like just one stapler, that's limiting the ability to divide up the work, right? We can have more and more people fold paper, but it still has to go through this one stapler. So it's not adding as much to our output. So notice here that that total product line gets flatter, marginal product starts to decline. Just because we're getting less and less from each additional worker doesn't mean we shouldn't hire them, because they are still adding to output. Okay. Well, when are we getting the most out of each worker? When do we get the most units produced per worker? That's when average product is at its max. And average product is always going to be at its max when it intersects with marginal product. Because when the marginal is above the average will go up. Right here, the average is going up. When the marginal is less than the average will go down. So where are your workers the most productive? It's going to be here at 6 units of labor, where the marginal product and the average product intersect. So we can see from these productivity graphs, when do we produce the greatest quantity? When do we get the most from our workers? When do we start seeing diminishing returns? If this is the short term, we're stuck with that fixed cost. So we have to recognize that we have the diminishing returns. Okay. If we're in the long run, if the contracts expire, we can get more. And then in the long run, we can deal with that diminishing returns by doing things like getting additional staplers. But we can't make decisions about how much to produce solely from productivity. Yes, we know when we can get the most made. Yes, we know when we're getting the most from each workers. Yes, we know when we're getting the diminishing returns. But how much we actually produce is also going to depend on the cost. So we also have to include measurements and graphs for cost.